This is the Trigonometry Need to Know series, just the basics to fix up any misunderstandings you've got and help you along the way. We've got the unit circle up first. So let's construct the unit circle. Now, when we're doing trig, we need to be using radians. So forget about these degrees. Let's convert everything to radians. So we always start on the right-hand side. That is an angle of 0. Now, as we increase the angle, we go in that direction anti-clockwise. Let's go up to the first quarter. That is going to be 90 degrees, otherwise known as pi on 2. Let's go to the next quarter, 180 degrees, that's pi. So that's one full pi. But let's go a full rotation, we get to 2 pi. And you can see that we're overlapping. 0 and 2 pi is in the same spot. So if we have an angle over here, then you can say that that angle is 0 or 2 pi, or actually 4 pi, 6 pi, 8 pi. The unit circle goes round and round. We get infinite solutions sometimes. So let's move on and let's look at the other special angles. This one is really cool because they give us our exact values. So we start off with the smallest angle, pi on 6. And then we jump up to our next angle. It's exactly halfway between 0 and pi on 2. That is pi on 4. And then we jump up here. Our largest angle, so that goes from 0 all the way up to the blue line, pi on 3. So these are our 3 angles in the first quadrant. Remember, we have these quadrants 1, 2, 3, 4, going anti-clockwise from 0. So let's move on to defining sine and cos. We're going to leave tan for another time. Let's just focus on sine and cos, because if you can understand that, you can understand everything. So given any angle from 0 up to some line, wherever that line hits our circle, we then project either down to the x-axis or across to the y-axis. And this projection gives us kind of this length. That is going to be cos. Cos is always that projection on the x-axis. On the y-axis, we have the sine of the angle. If you put in an actual angle, say 45 degrees or pi on 2, sine of that angle will be somewhere between -1 and +1. We can have negative values down here. We can have positive values at the top. Same with cos. It's going to be somewhere between -1 and 1. Because remember, it's a projection onto the axis. We're now going to convert any angle in the second quadrant to a first quadrant angle. That way we can use our exact values. So let's suppose we've got some angle here and we're going to write it in this form as pi minus this small angle. But we're really deciding what is the cos value of this angle here. Now remember that cos, if I dot down, I project onto the x-axis, I'm trying to find that length, and it's going to be negative. If I go and have a look at the first quadrant, let's reflect this angle A over to the first quadrant. I can see that that gives a positive cos value. So I'll take that, cos of A, but I need to put a negative in front of it because I need my answer to be negative. Let's look at sine. Remember that we're looking at this angle here. We're representing it as sine of pi minus A. And sine is always a projection onto the y-axis. And I can see that that is a positive value. So when I reflect my A angle over into the first quadrant, I project it onto the y-axis and I get a positive. So I don't need to introduce any negative. The first quadrant gives me a positive value and I wanted a positive value. Let's convert a third quadrant angle. We're turning this angle here, which is bigger than 180 degrees, and we're writing it as pi plus some small angle. Now cos of that angle is projected onto the x-axis, and we can see that it is negative. Let's put this A over into the first quadrant, project onto the x-axis. I can see that that is a positive value, so I have to introduce a negative when I write it as cos of A. Let's look at sine. Let's project the angle that we're actually looking for, projected onto the y-axis. I can see that is negative. So when I convert to a first quadrant angle and project, I get a positive value. Now that's not what I want. I want a negative, so I need to introduce a negative and then write sine of the first quadrant angle. Lastly, let's look at what happens when we have an angle that sits in the fourth quadrant. I've gone all the way from 0 to this yellow line, so it's a big angle. And I'm writing it as all the way to 2 pi minus this small angle. So 2 pi minus A. And like we did before, let's project onto the x-axis. I can see that is positive. And in fact, it's the same as my first quadrant angle. Exactly the same. So I can just replace that with cos of A, simplifying it, and my sine value over here, projecting, I can see that is a negative sine value. I want my answer to be negative, but if I look in the first quadrant, using the first quadrant angle, I can see that will be positive. So I have to put a negative sine A.